Hi, everyone, and welcome back to the 2023 Hack Summit. We're joined here by Michailo Jelek, who's the co-founder of Polygon. Polygon is on an incredible trajectory. They're one of the best scalability solutions for the Ethereum and EVM ecosystem. And we're just grateful that you decided to spend your time with us today to teach us today, Michailo. So thank you very much.
Thank you so much for the invite, and pleasure to be here. Hi everyone, I'm Michailo, one of the founders of Polygon, and I'm very happy and excited to share with you a little bit about our latest release, which is Polygon ZkEVM. As some of you might have heard, 2 days ago, basically, we released the mainnet of our ZkEVM, and I can just very briefly try to cover a little bit more about the topic and how we actually reached the mainnet, what was involved in the process. So hopefully you can get a better idea of how exciting and at the same time a little bit complex the process has been. So first, maybe we can start with a very brief explanation of what is Polygon ZkEVM basically, and why is it a big deal? Why is there so much buzz in the community about it? So Polygon ZkEVM and ZkEVMs in general have been considered, so to say, the holy grail of Ethereum scaling, if not Web3 infrastructure in general. And the reason for that is that ZkEVM is the only probably solution that offers 3 very important features simultaneously. One is scalability. So as you know, there is this pressing need to scale in Web3, and if we want to reach mass adoption, we need to significantly improve the scalability of the infrastructure, and ZkEVM is addressing that by utilizing zero-knowledge technology. The second feature is security. So again, by leveraging ZK technology, ZkEVM practically fully relies on Ethereum security, and as we know, Ethereum is the most secure, the most decentralized programmable blockchain in the world, and basically ZkEVM relies on this strong security of Ethereum without introducing any additional trust assumptions or requirements. You basically just trust math, that the mathematics or cryptography used in ZkEVM is correct. Otherwise, you have the same security like Ethereum. And the third important feature is the EVM compatibility. As we know, EVM is the standard, right, in Web3 for building applications. It's the default, basically, execution environment. And there is this whole thriving ecosystem built by different teams in the Ethereum community around EVM, everything from wallets, programming languages like Solidity, developer tools like Remix, Hardhat, etc. Like so many things that are needed for Web3 ecosystem has been built already around EVM. And if we can just inherit this whole ecosystem, it would be ideal, right? So if you have a solution, for example, that offers the first 2 features, the scaling and security, but you don't have EVM compatibility, you would probably need to build all the tools or most of the tools from scratch and change user developer experience and whatnot. So that would be a significant hurdle for adoption of such technology. So ZkEVM is a tech that offers all 3 things simultaneously, and hence why it has been hailed as the holy grail of scaling, and that's why it has been so highly anticipated. So hopefully this is helpful for those who don't have too much info about ZkEVM. And I think we can then continue to cover a little bit more of the features of the ZkEVM, Polygon ZkEVM itself. Just before I jump into that, one additional thing. So you might ask why we haven't had ZkEVMs before. They sound like an optimal or maybe even ideal solution. What are the concerns? What are the trade-offs here? So the major concern with ZkEVM has always been the complexity, number one. So it has been always the question whether it's possible to build first EVM, whether it's possible to prove all these complex operations of EVM, complex transactions. And the second of all, if it's possible to build, whether it's practical, right? It was, to be perfectly honest, it was a little bit unclear when we started working on ZkEVM a little bit more than a year ago. We had confidence that we can build it, but it was a little bit unclear whether we'll need maybe a data center to run these provers and generate these proofs. So that has always been the concern with ZkEVMs. Hopefully, we were able to achieve several engineering and cryptography breakthroughs along the way and make it very, very practical, as you will see in this presentation, and feature complete. And we are very happy and excited that we delivered it in a little bit more than a year, when basically people familiar with the matter estimated that it will take probably between 3 and 5 years maybe to deliver full-featured and practical ZkEVM. So that's why we consider this, and the community, I would say, considers ZkEVM and the fact that it's basically delivered and it's on Mainnet now such a big deal. So let's maybe dive into the features a little bit. So as we mentioned, there is this EVM equivalence, and the major benefits there is that we are inheriting the whole Ethereum dev and developer ecosystem and user tools and interfaces and everything, basically programming languages like Solidity. It's really a big deal, right? And to ensure this equivalence, we are using standard Ethereum test vectors, and currently we are passing basically 99.9 of these test vectors. The next feature we can mention are these complete and fast ZK proofs. We have been on this road to mainnet. Basically, we have been running Polygon ZkEVM on testnet for more than roughly 5 to 6 months, basically. And during this period, we generated more than 80,000 proofs for transaction batches successfully. We learned a lot. We improved a lot, as you will see during this presentation. But the fact that one of the things that we learned is that like people just simply can redeploy, right, their applications written in Solidity from Ethereum to ZkEVM, and they simply work. So these proofs can be considered complete as ZkEVM itself. We support all Ethereum opcodes and precompiles apart from free. So there are 3 remaining precompiles that we still don't support: Blake 2, SHA 256, and pairings. Everything else, absolutely everything else, is supported. And these 3 remaining precompiles are rarely used, really rarely used in practice. But there are some notable examples. For example, you cannot build layer freeze on top of ZkEVM today, because normally for that you would need pairings, and you cannot deploy, for example, Tornado Cache. I think these are 2 most notable examples of what you unfortunately still cannot do on ZkEVM today, on Polygon ZkEVM, but everything else, basically all other thousands of use cases and applications are perfectly possible and enabled on ZkEVM. Speaking of speed, right, of ZK proofs, we really have, as I mentioned previously, we have achieved multiple really significant optimizations, contributions from mainly Polygon Zero team, things like Starkey, like Plonky 2 libraries, very advanced cryptography and engineering implementations that allowed us to enabled us basically to achieve 40x, if not even higher acceleration, and really make ZkEVM practical. That was, as I said previously, one of the concerns in the beginning. High scalability. Two notable things we can mention here to achieve high scalability. We already implemented recursion. Recursion, for those who are not familiar with the term, are proving a ZK proof, or normally a set of proofs. So you basically can aggregate a number of proofs that you generated and prove that all these proofs are correct with one single proof. So that's recursion, and that gives you potentially high scalability boost. And we already have first implementation of recursion. Auto scaling of ZK provers, we already have on testnet and on mainnet implemented pipelining of provers, and we can elastically basically scale or spin up or shut down provers according to the demand on the network. just to double click on this scalability a little bit, we are currently able to prove 10 million gas unit in 2.5 minutes roughly on a single 60 core server. It's like standard AWS instance that's costing $2 per hour roughly. So this is like really something that we could have not, to be honest, maybe even imagined when we started working on ZkEVM. This one batch is costing, like when you recalculate everything, it's costing you roughly $0.064. Cost per transaction is below $0.001. This is average transaction, of course. Transaction vary in complexity on Ethereum, as you probably know, but this is just the average. And on the left side, you can see some stats, basically how many different types of transactions you can fit in this one batch. The next feature I want to touch on is decentralization. We are starting ZkEVM itself it has been a big quest for us, and we're starting with a centralized prover, like to the best of my knowledge, every other major rollup, but we have decentralization in mind all the time. So decentralization of provers is already implemented in smart contracts. It is just our proposal or first prototype implementation. Decentralization of sequencers is a work in progress. We have already proposed proof of efficiency consensus or decentralized sequencer and prover model, and we would like to encourage community feedback, and in the following months we will continue working on decentralization of the network. The network is fully, all the code is fully open source. We are very proud to share that. We announced basically ZkEVM fully in July last year at TCC in Paris. Since then, all repositories have been source visible, have been open right since that day. But with Mainnet launch, which happened on Monday, we decided and announced that the whole code, all the repositories will have AGPL license, which is if I can say, hardcore open source license, and fully following the Web3 ethos, and allows anyone to use with any permission from our side to use Web3 to use ZkEVM to experiment with it. So we are very proud, and we consider this a gift from Polygon to the whole community. These are some of the, all the repositories, and there are multiple prover implementations, different tools and libraries. We created 2 programming languages to build ZkEVM. One is PIL and the other one is ZkAssembly. We don't really have time to dive into that now, but just to cover this last feature, so to say, the production readiness. So as I said, we have 5 months experience on public testnet with prover running. That's also very important because now we have some, not to throw shade in any way on any other project, but many other projects are running testnets without prover. It's completely different game, and you get so much experience when you're running testnet with actual prover as you march towards Mainnet. This beta release has hit the Mainnet on Monday, as I said, and we had 2 external, very thorough, and 1 internal audits. So in a nutshell, I think this would be some notable features of ZkEVM. So just now to try to briefly cover what was involved, what has been involved as we were marching towards the Mainnet. As I mentioned, we have been running the testnet itself for more than 5 months. As I think mentioned, we have 80K plus complete ZK proofs, and this performance I think I also already mentioned. We have had multiple testnet upgrades and releases so far. Some of them improved deposit costs. Some of them were implementations of fixes that were of bugs and some issues that were discovered during audits. One of them was the new sequencer upgrade that significantly increased the throughput of the sequencer itself. And yeah, really a lot of experience, a lot of learning happened on this testnet, and it was a really precious experience for us. In parallel with running the testnet, as I mentioned, we performed multiple audits. I think it's fair to say this is the first, at least to the best of my knowledge, the first complete ZkEVM audit. These 3 audits that are mentioned here, this one that lasted 6 weeks, done by the SpareBit team, is really it really has been extremely helpful for us, and it was very thorough. The team audited all basically components of the ZkEVM. The team is really exceptional. It's comprised of some core Ethereum Foundation people, core Ethereum developers, people who really deeply understand ins and outs of EVM, and ZK experts as well. So all these 3 audits were extremely important, but I just want to mention and say a huge thanks to the SpareBit team. After all these 3 audits, we discovered, of course, several issues. They were fixed and checked by auditors, confirmed that the fixes were applied correctly. And yeah, that's something that also has been gain us basically additional confidence that we are ready basically for the mainnet. Of course, there is no zero risk, especially for a system like ZkEVM. As I mentioned in the beginning, ZkEVM is a very complex technology, and we have really done our best to have security as the priority. But of course, there is no zero risk, and every code has bugs. But yeah, I think we definitely reached the point where we have enough confidence to move forward with the mainnet. Of course, even though we launched the mainnet, we took internal steps to limit risks for users. There are certain warnings, notifications that are basically notifying users that the mainnet is still in beta, that they need to be mindful of the risks. We are trying to be also responsible in our public communication, and we have several internal measures, like sort of a kill switch implementations and security council, which is comprised of several prominent people, security experts from the industry, that can intervene in case of some problem. We have a comprehensive bug bounty program that we communicated over multiple white hat and security platforms and communities. We are continuously monitoring and improving the system. So these are basically more or less main measures that we are taking to keep the mainnet secure, right? So this is just kind of photo finish, or the last few months of this road to mainnet. As you see, just the chronology of these audits that I already mentioned, this bug bounty program. We launched internal mainnet, something that we didn't mention publicly. We basically launched roughly 2 weeks before the mainnet was launched. We launched these contracts and worked with them, monitored behavior internally without sharing anything publicly. And during those 2 weeks, we gained some additional confidence in the mainnet itself. We even had one thing that I can mention. We even had a trusted setup ceremony prepared for in case we were to use Grot 16, which is one of these ZK primitives or technologies that we considered using, but we ended up using another primitive called Flonk, and it turned out that we don't need a trusted setup. So, which is another great thing, because trusted setups, for those who don't know, there are certain ZK technologies that require something that's called trusted setup, and trusted setup is a certain ceremony that you need to perform in order to start using this specific ZK technology, and it if not performed correctly, it can introduce serious security concerns as well. We avoided, fortunately, this requirement for trusted setup completely by using Flonk, but we just had that as a backup option as well. Just to basically show that the ZkEVM team has several sub-teams who work together to make this happen, from the DevOps team, ZkNode team, UI team, protocol integrations team, the prover core team, product management support, and these people have been working basically for more than a year, almost year and a half, relentlessly to make this happen. Just to briefly, for us, this is a very, very important milestone for us, but it's just a milestone. We have so many plans with ZkEVM. We are not stopping here. There's really so much work ahead of us, and just a few notable milestones. We are slowly marching towards Type 2 ZkEVM. I will explain this in a moment. We have multiple ways how we can increase TPS and optimize ZK proofs. Like, we have, as I said, reached the point that we almost couldn't have imagined when we started, but now we see so much further potential for further optimizations, and we're very excited to pursue that now. Continue the improvement of security via audits and bug bounties. So hopefully the network will slowly mature, and we can then remove this beta, so to say, label, and proof generation, sequencing, decentralization. As I mentioned, we have decentralization in mind, and we're working towards it actively. I mentioned Type 2. So Vitalik Buterin recently introduced a taxonomy or classification of ZkEVM implementations in order to introduce some kind of clarity and order, so to say, in the ZkEVM efforts, because there are multiple of them. And Polygon ZkEVM is a Type 3 network, which means that it favors fast proving time, and in turn, as a trade-offs, we sacrifice a few of the opcodes. As I mentioned, free precompile opcodes, free precompiles are still not implemented, and we're going to implement them in the next 2 to 3 months, roughly. But for now, they're not implemented, so we don't support 100% of the contracts, but let's say 99 point something. And we made certain changes to the. We don't make any changes to the EVM itself, but the transaction tree structure, for example, and storage tree that is used in our EVM is a little bit different from Ethereum native blocks. So Type 1 ZkEVM is the ZkEVM that is identical basically to Ethereum, that use the same block structure, these data structures, etc. Type 2 is something that we want to introduce really soon, and we're working towards that. And Type 2 means that we will support 100% of contracts, 100% of these precompiles and everything, and we are pretty close to that. I would say it's a matter of a couple of months. After that, we will consider whether we want to move to Type 1. We don't have time to now analyze the trade-offs between Type 2 and Type 1, but it's like a little bit unclear what is optimal for Polygon, for example, Type 2 or Type 1, but that's something that we will decide once we reach this milestone of becoming Type 2 in a couple of months. Decentralization, as I mentioned, we have this already, the Security Council and this kill switch that is a current security measure in case, because the network itself is still not mature enough, the code is still not battle tested enough. So for now, we have the Security Council and kill switch, but we plan to remove that, of course, with time. We have centralized sequencer at the moment, but important to note is that centralized sequencers cannot impose any significant security risks to ZkEVMs because they cannot steal user funds. It's impossible with ZkEVMs. It's impossible to generate ZK proof for a malicious transaction, right? So centralized sequencers cannot steal user funds and withdraw them to Ethereum, for example. It is not possible unless there is a bug in cryptography itself. I briefly mentioned these long-term plans for decentralized sequencers, proof of efficiency, and things that we will be working with community to achieve decentralization of ZkEVM. Maybe just to briefly touch on onboarding. Onboarding has already started. We really have huge level of organic interest, and Polygon Labs, as well as one of the developing companies of Polygon, is working on onboarding solution providers, Web3 native projects, enterprise projects, and we are really seeing huge level of interest there. So that is going really well. And at the end, I can just say that I can just invite you to join this, what we believe is really the next chapter of Polygon and Ethereum, and give Polygon ZkEVM a try. And yeah, that would be it for me for today. And thank you so much for listening, and I'm available for any questions if there are any.
Thank you so much, Mihailo. That was very educational. We appreciate you going into all that depth with us. We're all very excited about ZkEVM, and we can't wait to play with it. I did a few questions just to help the audience have a better understanding of the product vision that you have for Polygon. So could you maybe give us just a very quick overview of what is an optimistic rollup versus a ZK rollup, and what are the trade-offs maybe between the two, and the advantage and disadvantage potentially between the two?
Yeah, it's a great question and pretty common one, of course. We support generally as integral part. Polygon is really integral part of the Ethereum community, and we support all meaningful scaling efforts, and optimistic rollups are definitely one of them. But we are having experience, years-long experience, even before Polygon, since the early days of Plasma, and which is very similar to optimistic rollups, basically. We have analyzed all these scaling approaches, and we formed a firm belief that ZK offers is basically the optimal way to scale Ethereum, because in optimistic rollups, the security of optimistic rollups is reactive, whereas security of ZkEVM is proactive. And by that I mean that in optimistic rollups, sequencers are able to submit malicious transactions and to at least attempt to steal user funds. They can try to withdraw on Ethereum, for example, but then you assume the existence of some entity that will challenge, that will notice this malicious attempt, and that will challenge using these fraud proofs that optimistic rollups use to challenge this malicious action and stop it. So you have this additional trust assumption of certain entity that is in some way incentivized to monitor, observe the system, and then react in case something happens. With ZK, you don't need that. The sequencer, as I mentioned, is not able to do anything malicious, right? It's impossible to generate a ZK proof. For that, that's one important thing. Another important thing is the user experience. With optimistic rollups, if you want to exit the rollup, for example, back to Ethereum, you need to wait for a certain period of time. It should be roughly between 1 and 2 weeks, because you need to allow this, what we call challenge period. You need to allow for some time, if something malicious happened, that anyone, as I mentioned, monitors the system and reacts, right? And this dispute gets resolved. So it's a significant, I guess, downside in terms of user experience. With ZK proofs, you don't need to do that. As soon as you submit the proof and proof is validated on Ethereum, you can withdraw your funds. And if you're submitting proofs every half an hour or 15 minutes, you can immediately withdraw your funds. And there are several other really arguments here, but we formed a firm belief basically that ZK technology is the way to go. It's in a way superior to optimistic rollups, I would say.
So last question then is, in the long run, do you believe that the ZkEVM will kind of replace the existing Polygon proof of stake scalability product, or do you think that they'll each have a role in the future?
Definitely, I truly hope so, and there's active work happening on that front. Like there's no reason, right, why Polygon PH chain, which has really high level of adoption, why it wouldn't leverage ZK security? There are only upsides, right, to that. And it's just a matter of complexity. Like with building Polygon ZkEVM, it's just a big and complex process, and also upgrading POS chain has its own complexities. So we don't want to commit to anything officially yet, but there is active work underway, and I really hope we'll be able to share something on that front.
Well, thank you, Mihailo. We're just about out of time, so unfortunately we don't have time to go into audience questions. But Mihailo, thank you very much for being here today. We learned a lot. We're very grateful for your time. If you learned something from Mihailo, donating to charity on our website, hacksummit.org, we'd really appreciate that. And Mihailo, thanks again for all your help today. So coming up next, we're going to be interviewing Stani, who's the founder of Aave. And so just stay tuned and we'll be right back. And thanks again, Mihailo.